Hello my dear students, welcome back. What a joy to see you. How was the quiz? Huh? It was easy? That's what Mr. Mike wanted to hear from you. You know why it's easy? Because you're the best. Mr. Mike always knew you're the best and you deserve the best, and that's what I'm bringing the best for you, and it's coming from the best. Alright, my dear students, in this sub lesson we're going to learn about reflection. Now, when I say reflection, when you look at the mirror, what did you see? The reflection of you. Do you see that? So that's what we're going to learn today, okay? The reflection. Alright, let's say for example, Mr. Mike got a mirror right here, okay? So we're going to take a reflection of who? Pablo. Pablo's not going to be happy, alright? Okay, let's say we got the mirror here. Now, Mr. Mac, let's say I want to put half of Pablo, alright? Let me put half of the Pablo, and look at that reflection. What does it gives you? Let's make Mr. Mac, look at that. Isn't that pretty cool? When Mr. Mac used to play, when I have a long mirror, when I go to the mall, where the clothing department, there's a long, when I was young, long time ago, okay? It was a long mirror. Mr. Mac would put half of Mr. Mac's face and the body, you know, and then I'll move my legs up and down, looks like as though, you know, I'm floating. You know, it was so funny because the other half of my leg is hidden behind the mirror, so I support that and then I carry my left leg up and down, so it looks like as though I'm like, you know, it is so interesting. My friend's got his camcorder, he start videoing me, you know, so we do all the goofy stuff. I know, when you're, you know, I'm sure when you're young you like to have fun, am I right? Like what you're doing right now, having fun learning mathematics. See that? Alright, okay, see that? So when Mr. Mac take half of Pablo, alright, I put right the center, okay? Okay, so now look at that. When I put right in the center, let's see, make sure Mr. Mac you can see that, okay? Now this is called the axis of reflection, okay? The axis of reflection. Put it right at the axis of reflection, and let's see, there you go, you can see Pablo. See that? See that? Okay, now if I had to move up, now Pablo got two hats, and then he got back here, okay? Oh, Pablo lost his eyes. See that? Okay, that's the reflection, okay? Now this is the axis of reflection, okay? Now let's say Mr. Mac take a piece of paper. Now let's do this. You do that too. Take a piece of paper, okay? Draw over anything you want, but half of it. Let's say Mr. Mac's going to draw, let's say a butterfly, okay? So I'm just going to draw a butterfly, okay? And that's the eyes of the butterfly. Okay, fancy one, alright? Okay, so right there, alright? So let me just put this marker down. Okay, now let's grab that paper that Mr. Mac just drew. Okay, now look at this. This half of the butterfly, I'm just going to put it right on the mirror. Okay, in other words, by the axis of the reflection. Okay, so let's make sure you can see it, because I want to make sure I line it up such a way that you can see it. Okay. Okay, can you see it? There you go. Alright, see that? It formed a nice butterfly. Okay, isn't that interesting? There we go, we got it. Alright, it's so hard for Mr. Mac to line it up and holding it and watching the camera so that it lines up right. But, okay, there we go, we got it. There we go. See that? Isn't that pretty cool? Okay, so that's the reflection. Now you notice that the image, okay, is laterally inverted to compare to the object, and this is the object, and the image is the one that's inside the mirror. Inside the mirror, that's the reflection. Okay, the reflection. All right. So see that? It's what again? Exactly. Laterally inverted. Okay, good. All right, good. Now, so you get the idea. All right, the reflection. Okay. Now let's take it to the board. Let's put it on the graph paper, and then we look at the reflection. Now, the keyword that I was using earlier, what was that? The orientation of the image. Now, what did I say when the orientation of the image? Laterally inverted. Alright? Laterally inverted. Another keyword that I use is the axis of reflection. Okay? So keep that two words in mind. Alright? So let's say, for example, let's say Mr. Mac let's draw a figure. Okay? Let's say if I draw a right angle triangle. Alright? Right there. Right angle triangle. Okay, right there. And I want to reflect this right angle triangle on the y-axis. My y-axis is going to be the axis of reflection. Alright, so my y-axis right there and x-axis right there. So if I to make this as my axis of reflection, so where would this triangle be? On this side, am I right? Okay, so now look at this. You take the each points, alright, on the reflection. Alright, so the reflection on the axis of reflection. All right, look at this. They are making a perpendicular line. Each point, pick 3 points, right there, point here, and then point here, and then point there. They make a perpendicular to the axis of reflection. All right, and bisectors. That means from here, 1, 2, 1, 2. There you go. That's the point for that. Let's say this is A, and that's A image. And let's say this is B. 1, 2, 1, 2, right there, and that's B. See that? Oh, this is B, okay? So that's the B image. And then this is C, okay? So perpendicular to the y-axis, which is the axis of reflection, all right? But look at what the distance is. 1, 2, 3, 4. 1, 2, 3, 4. Right there. And now let's draw that C image right there, and then let's draw that triangle. Now look at this. They're laterally inverted. See that? Now this inverted to the other side. That's what's called laterally inverted. Now look at the shape. Same shape and same size. Nothing changed. See that? It's only changes is what? It reflected. In another word, laterally inverted. Okay? That's the word I want you to remember. Laterally inverted. Y-axis is your axis of reflection. Okay? So now let's say I told you, let's use x-axis as your axis of reflection. So now you always keep in mind the perpendicular. It's a bisector perpendicular to the x-axis. Earlier was it's perpendicular to the y-axis and bisector. Alright? So that means this perpendicular line would be right here to the x-axis, and how many times? 1, 2, 1, 2 right there. And that's going to be your A image. Alright? And then the B, 1, 2, 3, 4. 1, 2, 3, 4 right there. B image. And then C, 1, 2, 1, 2. See that? C image. Okay, now let's draw the triangle. Let's darken up. See that? It reflected. Okay, and this is axis, your x-axis is your axis of reflection. And look at this. This is called perpendicular line, all right, to x-axis, and they're bisector. So if this is the distance from A to the x-axis and the distance from x-axis to the A image are same. 1, 2, 1, 2. Now look at this one also, C, and the C image. See that? 1, 2, 1, 2. And then B. 1, 2, 3, 4. 1, 2, 3, 4. See that? And they are laterally inverted. Okay? Because you notice that from our translation, what happens? If I to move it to this, the image of this object will be this way. See that? But reflection is laterally inverted. Reflection is laterally inverted. Okay? So what are the key things that you need to know on the reflection? The shape are same, the size are same, except they are laterally inverted on the axis of reflection. Okay? Very important, okay? The orientation. If I ask you the orientation on an object to the image of on reflection, it's laterally inverted. Okay, so I can give you any object. All right, you should be able to find the reflection. All right, so it's pretty straightforward when I give you in this. Okay, now let's say for example, Mr. Mac to put a line in the middle right there, right in the center, evenly. Let's say if it's a 1, negative 1, 2, negative 2. In other words, all these points, okay, along this. Okay, so right on the center of the diagonal. All right, okay, see that diagonal line right here? That's going to be my axis of reflection. Okay, I'm going to use that axis of reflection. Let's say for example, if I to draw a triangle right on it, right there, right there. and reflecting right there. Okay, so keep in mind this point will make a perpendicular to this axis of reflection. Okay, and then perpendicular straight goes up, and the distance, it's going to be same, bisectors, and that's where the point is going to be. And this point pretty much reflects right on top of it. So if I had to join them, right there, see that? Okay, so let's see if I had to put a circle. Let's say I put a circle. Or oval. Let's just say oval. Okay, and it reflects back. This one right there, perpendicular, and the same distance is going to make right there. See that? And that's the axis of reflection. See that? Now let's say for example, Mr. Mac to put a square over here. Draw a square. Okay. Now this point and this point makes a perpendicular right there, and you extend this perpendicular line. Okay, extend that perpendicular line. All right, extend that perpendicular line, and then look at the distance. 1. That means 1 right there. Look at the distance. 1, 2, 1, 2 right there. Okay, the same thing with this one. If I had to use a perpendicular line and then extend that, and the same thing with this one, perpendicular line, extend that. This is 1 and a half, half and 1 right there. 1 and a half, half and 1 right there. Right there. See that? That's the reflection of that triangle. That's the reflection of that square into that on the axis of reflection. See that how it works? See how Mr. Mac drew a perpendicular line. This line has to be perpendicular. This line has to be perpendicular. Of course, since it's a graph paper, I know from this point to this point to this point, it makes a perpendicular to that. As long this one is right on diagonal, okay, bisecting this angle, okay, the 90 degrees. In other words, this is pretty much 90 degrees. It's bisector of these two axes, x-axis and a y-axis, a bisector. If that is my axis of reflection, I can use this principle. All right, what I just showed you. Okay. Okay, so well, let's say Mr. Mac to give you a coordinate and ask you to find the reflection, okay, on the axis of reflection. Okay, let's say for example, Mr. Mac give you, let's say this one right here. All right, and this is, let's say, U, and I want you to find the image of U, okay, the image of U, of the object U here, on the y-axis as your axis of reflection. So how do you do that? And you know that the key thing when we talk about reflection, okay, when you're given the axis of reflection, you find the perpendicular line, that bisector, okay, a perpendicular and bisector, perpendicular to the axis of reflection. In this case, perpendicular to what? Y-axis, okay. So that means if this is the y-axis, perpendicular makes a right angle at 90 degrees. So this is pretty much the line that makes 90 degrees. See that? So what's the distance from the axis of reflection to the point, the object coordinate? All right, so it'll be 1, 2, 3. So that means you measure again another 3. 1, 2, 3 on this side, because they're bisector. See that? When you say bisector, the distance from here to the axis of reflection will be same as the distance on the image to the bisector. I mean, image of from the image to the y-axis. All right, another word, axis of reflection. Okay, so this is going to be your U image. All right, the image of U. All right, so now if I want to find the point, now first let's find out what is this coordinate. All right, so let's label them. This is 0, -1, -2, -3, -4, -5, 1, 2, 3, 4, 5, 6. Okay, 6, and then 1, 2, 3, 4, 5, 6. And then -1, -2, -3, -4, -5, and -6. Okay, now what's the coordinate for U? So -3, and 5. See that? Negative 3 and 5. So that means negative 3, 5. Now, let's find what's u image, the image of u. 3, 5. See that? So 3, 5. Now look at that. Negative 3, 3. Positive 5, 5. Positive 5. The y coordinate pretty much stayed the same. Only what? The x is the one changed from negative to positive. See that? So in other words, if I use the y-axis as my axis of reflection, the y coordinate remain the same, doesn't change, only the x changes. Okay, so again, if I use y-axis as my axis of reflection, okay, the y coordinate does not change, only the x changes. If it's a positive x, it'll become negative x. If it's a negative x, become positive x. Alright, now let's say for example, if I had to give you a point right here, alright, and I told you what, let's find out what the point is. 4, 1. 4, 1. And I told you that point, let's say it's v. Image, find the image of object coordinate v. Alright? Okay, so I ask you to find the image for v with axis of reflection on y-axis. So you know it's going to be what? The y going to stay the same, only the x going to be changed. From positive 4 becomes negative 4. So in other words, the v image could be negative 4, 1. Okay, let's see. Negative 4. 1, 2, 3, 4. See that? Negative 4 and then 1 right there. Let's see if it's correct or not. Alright, let's prove it. The image. This is the perpendicular line to the y-axis. And let's see the distance of the bisector. 1, 2, 3, 4. 1, 2, 3, 4. It is. See that? Okay. Now let's say for example, if I give you a point. I told you the point here is this one right here. Let's say this is M. And I want you to find the image of M reflected on x-axis. The x-axis now is the axis of reflection. Alright? So this is going to be our reflection. So now we want to find the perpendicular line. Alright? That's perpendicular to x-axis. This is the one right there. See that? Makes it 90 degrees right there. See this line? So we want to find the distance. 1, 2, 3, 4. 1, 2, 3, 4 right there. And that's going to be my M image. Now let's put the coordinate, okay? So let's find M coordinate is negative 1, negative 2, negative 3, negative 4, negative 5. So negative 5, 1, 2, 3, 4. 4. Alright, let's find the image, okay? Image is also negative 5. And then 1, 2, 3, 4. Okay, negative 4. Look at this. Negative 5, negative 5. Positive 4, negative 4. See the opposite. When I had the y-axis as my axis of reflection, negative 3 and 5. 3 and 5. Which one changed? The x coordinate changed. See that? Negative 3 become positive 3. But look at the y, never changed. But look at that. When now I changed it to the x-axis as my x-axis, okay, axis of reflection, negative 5, negative 5. Positive 4, negative 4. Who changing now? The y. So when you're reflecting on x-axis, x remains the same. It's only the y that changes. Okay? So in other words, if it's a positive y, it becomes negative y. If it's a negative y, it becomes positive. Okay? Let's say for example, Mr. Mac, pick a point. Let's say a point right there. Okay? Let's say this is t. Okay? So what's the coordinate for that? T is 1, negative 5. Okay? When I reflect on x-axis, which will be my axis of reflection, so x-axis, x stay the same, y is the one change from negative to positive. So it's going to be, so my t image going to be, x going to stay the same, it's going to be positive 5. Let's locate positive 5, okay? I mean 1, 5, the coordinate t image. So 1, 1, 2, 3, 4, 5 right there. And that's going to be my t image. Okay, let's see if it's correct now, okay? Perpendicular line. See that? It is perpendicular right there, okay, to the x-axis. Now let's see the distance, the bisector. That means from image t to the x-axis, distance should equal from the x-axis to the t, the object. Alright, so let's see. 1, 2, 3, 4, 5. Now let's see if it comes 5. 1, 2, 3, 4, 5. Like this. See that? So that means T reflection is T image right there. That's what the bisector means. The perpendicular line bisectors. Okay? The reflection line, the axis of reflection is bisecting the perpendicular line. Alright? That's why the distance are seen. Does that make sense? Pretty easy, isn't it? Straightforward, okay? Now, what happened if it's the diagonal, the bisectors? The diagonal that bisectors the y-axis and the x-axis. So pretty much this line right here. See that? That diagonal right there. It's a bisector. Okay? So if I had to put a point right here, let's say this point right there. Let's say this is, let's say we say S. Alright? Let's find the coordinate for that. Coordinate for S is -5 and 2. So -5, 2. Alright? So we want to find the reflection of the image of S, and reflection on this diagonal line right here. Okay? So this is going to be our axis of reflection. So how do we do that? First we find the perpendicular line to this axis. Okay? Axis of reflection. So you know that it's perpendicular line is going to be right here. Because how do I know that? Because see, this is kind of like a square. Okay? So when the line goes right in the center like this, that's going to be perpendicular. Now this is 1.5. Okay? That means half and 1. See that? So it's going to be right there. That's going to be the S image. Alright? Now let's find out what's the coordinate for the S image. Alright? So see that? Why did I say this is 1.5? Kind of like using this distance. You know? 1.5, half and a 1. See that? It means the distance same. Alright? The distance same. Okay? So that because it's perpendicular and bisector. Okay? So now let's find out what the image coordinate is. Alright? So -2, 1, 2, 3, 4, 5. 5. See that? -2, 5. Now look at this. The object and the image coordinate. -5, 2. And this time it becomes -2, 5. Okay, so it's very important, okay? See that? -5, 2, -2, 5. Alright, let's pick another point. Okay, let's say for example, Mr. Mac to pick a point, let's say right here. And let's say this is W. And I want to find the image of W. Okay? Using the reflection, axis of reflection of this diagonal line right here. Alright? Now, keep in mind, alright, you gotta draw a perpendicular line from this point to the axis of reflection. Alright? And then the distance from the point to the axis of reflection, okay, equal to the on top of the perpendicular. When you, let's say for example, okay, Mr. Max is going to draw the perpendicular line, right? So how do I know? See, because this is a graph paper, and it's very easy for me, because this is a diagonal which is bisectors the x-axis and y-axis, I know I can use this idea where it goes in between this, see that, like this, like that. Okay, that is for sure perpendicular. Okay, that line is perpendicular to this axis of reflection, alright? So I know that's perpendicular. Now I got to measure the distance, which is 1.5. Let's say 1.5. All right, we just use it as 1.5. That means this is also has to be 1.5. So pretty much half and 1. See that? Pretty much 1.5. So that means this W image is going to be right here, and that's the W image right there. See that? Okay. So now let's find the coordinate of this one. This one is 0, -3, 0, -3, okay, and the reflection becomes 3, 0, 3, 0. Very important. It has to be perpendicular to the axis of reflection, and then the distance has to be equal. All right. Now, because it's a graph paper, we're able to sketch it on it and find the perpendicular line. Now what happened if I had to draw an image like this? And I told you this is the axis of reflection. Okay, so now I give you this object and I want to find the reflection. I want to find the image of this object using the axis of reflection given right there. How do we do that? Now, when we had this graph paper, it was pretty easy. We can be able to measure it, or we're able to draw the perpendicular line. But in this case, you don't have a graph paper. That's where comes our tools, our compasses and straight edge. Alright, my dear student, let Mr. Mac erase the board and let's learn how to draw, okay, the reflection of this object. I'll be back in a few seconds. Alright, my dear student, now let's say for example Mr. Mac got an object here, okay? I want to find the reflection, okay, of this object on an axis of reflection if I gave you that. Okay, let's say for example Mr. Mac going to draw this triangle, okay? Let's draw this triangle, alright? And then after I draw this triangle, okay, I'm going to give you the axis of reflection. So let's say I told you this is the axis of reflection right there. Okay, this is the axis of reflection right here. Okay, and I want you to find the image of this object reflecting on this axis of reflection. Okay, so how do we do that? Now, what are the key things that we need to know? First, when we have a object, the object is, in order for that to reflect on this axis of reflection, all right, first this points right here, all these points has to be perpendicular, all right, perpendicular to the axis of reflection, all right. So I got to find a perpendicular line from this point to this point to this point and this point, all right, and then the distance from this point on that perpendicular line to the axis of reflection, it's same as the point on the image. Let's say for example, let's say this is A, okay, let's say, and this is the perpendicular line, all right, okay, makes 90 degrees, and then let's say this is the A image, the distance is going to be identical. If this is 3 and this is going to be 3, like that, all right, okay, so the distance, let's say this is A, this is going to be A. The same thing I do, I find a perpendicular line from this point to the axis of reflection and then extend it, and then I find the distance should be right there. Okay, so let's do that. So we want to draw a perpendicular line to this axis of reflection. Okay, so we need the compasses. Okay, Mr. Mac got a compasses here, alright. So how do we do? First we take the sharp point of your compass right here, the compasses, okay, I want you to put on the one of the points. Let's start with this point right here. We're going to put it right there, all right, and then I'm just going to mark 2 points, one right there and then one right there. Okay, so mark 2 points and then make sure you don't change it. Okay, pull it out and then put it right there and then mark one right there, and then see if that one crosses with another one right there, crosses right there. Okay, so now that is the perpendicular line. So I'm going to take a straight edge, I'm going to join this point and with that point, that creates a perpendicular line, all right, to the axis of reflection. So let's draw the line, make sure lined up right. Okay, so once lined up right, I'm just going to use the straight edge and then I'm just going to draw the line. Okay, okay, good, right there. Okay, so that is the perpendicular line right there. The next thing I want to do is I want this distance and I want to create to that one. They have to be identical. So now I have to measure from the point here to there. Okay, let's measure that. Okay, let's use this. All right, so it gives me up to here right there. All right, so I'm going to go right there and right there. That's my first point right there. Okay, let's label that triangle. Let's say this is A, B, and C. So the image C is right there. All right. Okay, so we done that. Okay, so now let's do the B. Okay, so let's do B. Now let's erase this because we don't need this, because this is something we just did ourselves. So let's erase that. Alright, okay, so let's do B. So what do you want to do? Take the compasses again, the sharp point, okay, put it on B. Alright, so find two arcs on this axis of reflection. Okay, so let's just find anywhere. Alright, let's say one right there and another one is right there. Okay, so you got 2 points right there. Alright, two arcs. Okay, and then the point is the one was the intercepting. See this point right here, this point and this point, where the axis of reflection is intersecting on the arcs. Alright, now make sure you don't change the size of the compasses. Alright, now take the sharp point and put it on this point right here. Alright, and then create an arc. So we're going to create an arc right there, and then we're going to do the same thing right there, create an arc. Alright, so we're going to create an arc. So make sure you get an intercept right there. It's intercept right there. Okay, so we're going to take this point and we're going to join with the point B. Alright, so that's the image. Okay, that's going to be our B. Okay, image of B. Alright, so let's take the straight edge and then we're going to join B to A, the B image. Okay, so we're going to join them. Alright, let's line it up. So then we're going to put a straight edge because that makes the perpendicular line. Alright, that's the perpendicular line to the axis of reflection. Alright, let's just draw that. Okay, so now we want to find the distance from this to the axis of perpendicular axis of reflection. Okay, so let's measure that. So that gives me 4. Alright, 4. So we're going to measure that 4 right there, perfect, right there. Alright, and that's the B. Alright, I shouldn't have rushed it, I shouldn't have labeled it yet, because that shouldn't be a B image yet, because I have to measure first. I have to measure first and then make sure it is 4 and 4, and then only I should say this is the B image. See that? Okay, because that was just a construction point so that I can create the perpendicular line. Then I measured, it happened to be 4 and 4, alright? But I shouldn't mark it right away. I should measure first. Okay, 4, 4, there you go, right there. Let's take our compasses again. The sharp point is on the A, and then you can just mark anywhere here. One arc here and then another arc there. Alright, pull it out and then put it right there. Then create another arc there and then another arc there. So look for the intercept right there. That's the intercept right there. And then join the A to this point right there. And then we're going to join those 2 points, and the point and the intercept. So that makes this one, oops, Mr. Mike dropped the straight edge. Okay, that's going to be, this one's going to be perpendicular right there. Okay, so now we're going to measure from A to the axis of reflection. Okay, so let's take that. So that gives me 1. So that means it's going to be right there, 1. So perfect, right there. And that's my A image. Now let's join them. All right, A to B, B to C, and then C back to A. Let's do that. So let's do the B and C. Let's join that. Okay, and then A and B, the images. Okay, so we're gonna join them, and then C image with the A image. Okay, look at that, the reflection. See that? Now let's, Mr. Mike, grab this. Let's put it right here, right there. See that? Isn't that awesome? Alright, my dear student, we just learned how to draw an object, reflect on an axis of reflection, and the image is right there using the compasses and a straight edge. You did an awesome job, and I know you've been doing along with Mr. Mac as I'm showing you. If you didn't, do it, okay? Rewind this video and watch how Mr. Mac doing, and then I want you to do it because it's good for you to learn how to do that. Alright, my dear students, this is perfect. You learn a lot about reflection. Okay, well, it's time for hands-on practice. Okay, so let Mr. Mac erase the board, and then let's see what Pablo's doing. He's busy using the straight edge and the compasses as well. Okay, good. It's preparing the hands-on practice, okay? So let Mr. Mac erase the board and I'll be back in a few seconds and then we'll call Pablo out and we'll have fun with the hands-on practice. Alright, my dear student, I'll see you in a few seconds. Alright, my dear students, are you ready for some hands-on practice? Alright, let's call Pablo, okay? Pablo, come on over, Pablo. Bring over the hands-on practice. Our dear students are ready for hands-on practice. Alright, my dear students, yes, Pablo is going to hand over the worksheet. Now, once you receive the worksheet, be sure to pause the video. Now go ahead, use the compasses and the straight edge to draw the reflection, alright? Okay, here it is, have fun. Good. Alright, how was it? Pretty easy, isn't it? Straightforward. Okay, let's do it together, okay? Now, problem number 1. Under the reflection of line MN, find the image of the object, okay? So, I also told you, use the compasses and straight edge, alright? Okay, let's do it. Let's write down. You're given problem 1A. 1A, you're given a line MN. So, MN. And then you're going to point right here. And you want to find the reflection of this point. Now, what is the key thing that we need to know? In order to find the reflection of this, in other words, the image of this object. So in other words, we're going to find it right there. So if this is the reflection line, and we want to create a perpendicular line, because the reflection line with the point, you want to create a perpendicular, and then you measure the distance, and then you measure on the other side for the image. That's where you locate the image, alright? So in order to draw the perpendicular line, what do we need? Exactly, we need a compasses, alright? Let's start with the compasses, okay? So grab your compasses, and always remember this is going to be your pencil, and this is going to be your sharp part of your compasses, okay? So we're going to take the sharp part of the So we're going to take the sharp part of the compasses, we're going to put it right on the R, okay? And then we're just going to mark 2 arcs on this line, alright? See that? One right there, one over there. And then pull the sharp part out of that. Make sure you don't change the length, alright? And then position 1 right there, okay, on where the arc and the line intercept, okay, that point. And then create another arc here. And then put it right there. So in other words, I'm looking for this point right there. This point and that point. Okay, that's why you want to put your sharp point of the sharp part of the compasses on this one right here. We want to put right on this dot right there. Intercept right there. So I'm going to put right there and then create my goal is to create a intercept of the 2 arc. So and now I take that point of intercept right there. See that? And then I'm going to draw a straight line. All right. So that is the perpendicular line to MN. So if that is perpendicular, then that means that's where the reflection is going to fall along that line. So we're going to find, now we're going to measure it. So now we're going to measure from the point here to the line of reflection, okay? So we're going to measure and see what's the length is. Alright, so we're going to put it there. So it gives me 2. So I'm going to come up here and then look for the 2 right there. Okay, so it's fall right there. And that is the image. So that our image. See that? The key thing is I want you to learn is how to draw the perpendicular line from the point to the line of reflection, the MN. Alright? Okay, good. Now let's look problem B. Now B, you're given a line this time. Alright? So let's see number B. B this time, again we're using the same MN, alright, the reflection line MN, and then we're given a line UV, alright. Okay, so let's put a point to it, alright. So we want to do what? We want to create a perpendicular line on the point U and point V. That's our goal is. See that? So once we create perpendicular line, and then we know that this point is going to fall along this line, the reflection, the image of U. all right? But how do we know where it's going to fall? We're going to measure the length. The same thing with this one. This is going to fall along this line right there, and then we're going to measure the length of this length, because it's going to be same identical, because we want that this line is bisecting, okay? Bisector this perpendicular line, so that this distance, that distance will same for us to locate the V image and the U image. See that? That's our goal is, all right? So let's do that, okay? So let Mr. Mac erase those. This thing that I hand sketched it, all right? So because we're going to use the proper tool to find the perpendicular line, all right? So what we needed? We need the compasses, okay? Let's grab the compasses. Okay, first we're going to do for U first, okay? Take the sharp part of the compasses and put it on the point U, and then create two arc, all right? So it looks like I need the line a little bit longer. So let's draw the line a little bit longer, okay? So should I use straight edge to draw that line, okay? Mr. Mac just kind of used hand. I cannot do that, all right? Let me erase that. So I cannot just simply use my hand to draw that straight line. It has to be perfectly straight in order to create a perpendicular, am I right? So let's just put a one long line, and then take the M and N out, and then put M here and then N here, all right? Okay, now then I'm going to take the compasses, take the sharp part of it, I'm going to put it on M. Okay, so now I'm going to take the compasses, the sharp part of the compasses, I'm going to put on the U, and I'm going to create two arc, one right there and one right there. Okay, and then I'm going to pull it out, and then I'm going to put it on this intercept right there, one right there, and right there. My goal is to create a intercept, all right? So I'm going to do the same thing over here right now for V. Okay, so I'm going to make it a bit longer. So one right there and one right there, and then I'm going to put it right here. One arc, make sure a long arc, so that, okay, another one right there, right there. Okay, good. Take it right. Okay, let's see. Yeah. Okay, good. All right. Okay, looks like I got 2 points. I'm looking for these 2 points, all right, and this two, and this one, all right. My goal is to create a perpendicular line from point U to the MN, all right, the line of reflection. So I'm going to join those 2 points. Okay, I'm going to join these 2 points right there. Okay, that's the perpendicular line right there. Okay, but what I did earlier with the compasses, that create a perpendicular line, and then I'm going to do the same thing with the one, this point and that point, and then I'm going to join them. Okay, all right, there we go. Okay, now what's our next step? We know this line is perpendicular, right? These two lines are perpendicular to MN, and then I'm going to measure the distance from U to the MN. Okay, the reflection line. All right, so let's measure that. Okay, let's see, it's right there, and then it falls right there. Okay. Okay, then we go back here, we measure it, same thing right there, and then right there, that's the point right there. That's my U image, okay? Now let's find V image. V image, we'll measure it again. From there, it comes to right there, right here. Okay? Okay, so I'm going to come up here, right there. Okay, and that's my V image. So now I'm going to join those 2 points. See that? And there you go. You got UV image line. Okay, that's the image right there. Right there. See that? Okay, see the reflection. Because look at this. The orientation. Okay, what is that? Laterally inverted. Laterally inverted. See, that's what the laterally inverted. See that? Okay, all right, good. Okay, so see that? Pretty straightforward, isn't it? Okay, now let's do C. How about Mr. Mac erase the board, and we'll do problem C, and I'll be back with you in a few seconds. Alright, my dear students, so let's do C, okay? Now C, we're given a triangle, so let's draw the line MN, alright? The line of reflection, okay? So we're doing C right now, so let's do the line of reflection, and then we're given the reflection line, then we're given a triangle, okay? So the triangle right here, so just draw any triangle, alright? Okay, so let's just do that, and then let's label it, okay? Label that triangle, okay? So the triangle's been labeled A, B, C, okay? So A, B, C. Okay, so we want to find the reflection on the line of reflection of MN. All right, MN. Okay, so what are we going to do? Exactly, we're going to create a perpendicular line from point A to the line of reflection, perpendicular line from point B to the line of reflection, and then point C, perpendicular line to the line of reflection. Okay, so how are we going to do that? We're going to use a compasses. Okay, so let's grab the compasses. Okay, and then take the sharp point, put it on the A first. Okay, so let's create two arc. So look like we may want to okay, right there, and then one right there. Okay, and then take the sharp point again, put it on the intercept of the arc and the line, MN line. All right, and then right there. Okay, so let's put it right under the sharp point, and then create an arc there, and then create another arc. So the purpose of creating two arc is so that we can find the intercept. All right, right there. See that? And that will create a point. So now we can take a straight edge and create a straight line connecting that A to the intercept, and that line is perpendicular to line of reflection of MN. All right, so we're just going to create a one straight line, and this line is perpendicular. See that? Okay, now we're going to measure it. So we're going to measure, okay, from the line of reflection to A. So we're going to put it, it's going to be right here. Okay, so then we're going to mark it there, and then we're going to put it right here, and then yeah, right there. Okay, that's that right there. Okay, that's the A reflection. Okay, that's the image. All right, A image. We already found A. Now let's find B. So how we do B? Do the same thing. Okay, take the compasses, take the sharp point. In your case, will be the sharp point, and then put it on the B, and then put a two arc. See that? So one is right there, and one is right there. Okay, so very important. Okay, the two arc. See that? Okay, and then this point right here, and you're going to use that point right there. You're going to use a reference point. Okay, to create another two arc over here that intercepts. Okay, so let's put right there, and then make sure don't change the size, the length size. Okay, very important. All right. Okay, right there. Okay, now we found another point right there. Now we're going to connect B to that point, and that line, when I create the line, when I connect the point with creating a line, that line is perpendicular to MN. Okay, so let's put the straight edge, line them up, and then draw the straight line. Okay, so this line is perpendicular. All right. Okay, so now we're going to measure it. So we're going to measure it. So from line MN to point B, it falls right there. Okay, so it's fall right there. So we're going to take it right there and measure. Make sure. And okay, it fall right here. Okay, so that's the B image. All right. Okay, so now we want to do for C. Okay, so take the sharp part of the compasses. Okay, put it right on the C. Okay, so then, all right, once you do that, and then put it such a way that you can locate one point, one arc on this side. So in this case, right there, and another one is right this side. Okay, see that one right there, and that one right there. So you need 2 points. Okay, the intercept between the MN line and the arc right there. The intercept right there and right here. Okay, so we're going to use those 2 points, okay, to create another 2 arcs. Okay, so you take the sharp point and put it on that one. Okay, right there, and then create an arc, and then do the same thing on this one, create another arc. See that? Intercept. This is a very important, you need this point. Okay, now we're going to join those 2 points, the C with that. Okay, so that create a perpendicular line. Alright, when I join those 2, okay, that we're going to create a perpendicular line, a perpendicular to MN. Okay, that's our goal, is to create a perpendicular line right there. Okay, so this line is perpendicular. Now I'm going to measure it. We're going to measure it from C to line MN. Alright, so right there, and then I'm going to just mark it right here. Okay, and then I'm going to move it right there, and then I'm going to position it such a way it's right there, and then locate the point right there. It's right there, and that's going to be your C image. All right, so now what are we going to do next? We're going to join all those A, B, C. Okay, let's join A, B first. So A, B, so let's draw a line that connecting A, B, and then BC, okay, BC, and then AC, okay, so AC right there, right there. See that? The image reflected on the line of reflection of MN. Pretty easy, isn't it? Alright, good. Okay, good. That's for C, okay? So now you understand how to draw the reflection of a point, line, and an object. Alright? So right there, boom. Okay? The key thing is you got to understand how to draw the perpendicular line. Pick, if it's an object, pick the corners, the vertex of that object, points. Alright? Now if it's a line, the 2 points. If it's a point, just a point. Okay? Create the perpendicular line. Alright, good. Now let's look at problem number 2. Now they said find the coordinate of the image of S under the reflection of x-axis. Okay, so in other words, say we know that number 2, now if this is y-axis and this is x-axis, alright, so we're asked to find the image. Okay, so S is 4, -3, so that means it's a positive 4, which is mean to the right, okay, on the x side, and then goes down by -3, so somewhere around here. Okay, so where the reflection is going to be on x-axis, this is x-axis, alright, that means this is going to be right here, alright. So we know that when it reflects on x-axis, x doesn't change, only the y coordinate change. Alright, so in other words, we're given 4, -3. So when it goes up here, perpendicular, that means 4 stay the same. The x-axis, the 4, the x4 will stay the same all along this line right here. See that? So it only that y changes. But we know that -3, if this side, I mean, in other words, it's a distance of 3, and it's going to be 3 on this side also. That means it's going to be what? +3. So 4, 3. See that? It's the y changes the sign. When you reflect on x-axis, it's the y coordinate that changes from negative to positive to negative. So that's right there. So S, so the S image is going to be 4, 3. Okay? Does that make sense? Always keep in mind. Alright, let's see for example, Mr. Mac to give you another point right there. Okay, I told you it's -4, let's say 2, and ask you to find the reflection on x-axis. So that means it's going to be perpendicular to that x-axis. Okay, it's going to be perpendicular. That means who's going to stay the same along this line? -4 going to stay. So that means any point I pick, it's going to be -4, -4 for x. It's the y is the one that's going to change, and we know that it's going to be 2, so that means it's going to be 2 right here. If it's a -2, it's going to be +2, so it's going to be -4, +2. See that? The -2 of the y coordinate is the one changes to +2. Okay, but the x stay the same. X stay the same. Alright, okay, good. Let's look problem number 3. Number 3 says find the coordinates of the image of T, which is 8, 6 under the reflection of y-axis. This time we're doing y-axis. Alright, so problem number, let's see problem number 3, okay? So you're given T, 8, 6. And the reflection is on what? On y-axis. This time we're reflecting on y-axis, okay? So if I were to draw the, the y and x-axis, alright, so let's say 8, 6 is going to be what? Let's say 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So it's going to be, let's say right here, alright? Okay, so let's say it's right here. And that's T, 8, 6. Now it's reflecting on what axis? Y-axis. See that? That means it's going to be right here. See that? That means this line is what? Perpendicular to y-axis. So along this line, who stays the same? Exactly, the y coordinate. Any along this perpendicular line to y-axis I pick, y coordinate is going to be always going to be what? 6, 6, 6, 6. Always going to be 6. If the x is the one changes. So we know that the distance from that point to the y-axis is 8. So that means we're going to create an 8 right here. See that? Right there. This is going to be 8 also. Okay, that means, what does that mean? Your x-axis is going to change, but not y. But y is going to stay the 6. But x is going to become -8, because this side is negative side of the x. This side, the positive side of the x. This side, the positive side of the y, and negative side of the y. See that? So let's say I give you another point. Let's say if I pick, let's say right here, and I told you it's, let's say negative 4, negative 1. All right? Let's say negative 2. And reflecting on y-axis. Okay? So that means it's going to be a perpendicular line. All right? That means x is going to be different. All right? So y is the one that's going to stay the same. Y is going to stay, no matter where I pick, y is going to stay the same. It's the x. So that's what we're looking for. What the changes on x going to be. Because we know it's going to be what? 4. And here also going to be 4. How do I know 4? Because it's that negative 4. The negative, it just tells us the negative side of the x side. Alright? The distance, the length is still going to be what? 4. 4, 4. That means this will be negative 4 become positive 4, and y becomes 2. It stays the same. Doesn't change. Alright? So keep in mind, when you're reflecting on y-axis, y-coordinate doesn't change. When you're reflecting on x-axis, x doesn't change. Easy, isn't it? It's the y-coordinate that change for reflecting on x-axis. From positive becomes negative, negative becomes positive. And same thing with this one. From positive becomes negative, negative becomes positive for what? For x, because y doesn't change when you're reflecting on y-axis. Alright? So keep in mind, y doesn't change on y. See that? Y-axis, y doesn't change. X-axis, x doesn't change. Alright? Alright, my dear students. That's the end of the hands-on practice. Good job. I'm so proud of you. You did a great job and you learned a lot. Okay? Alright, good. Go take the quiz, and then I'll see you on the next sub lesson. Alright? And I'll be waiting for you. Have fun, my dear students. Bye-bye.